Hello everyone, welcome to my YouTube channel. Hope everyone is good. So, we were talking about statistics in our earlier videos. So, moving forward in that journey, in this statistics playlist, we will add this discussion on charts and graphs. My name is Devanshu. So, why charts and graphs are important, we should know. So for example, there are many visualization softwares like Power BI. You can do visualizations in Excel. Tableau is there. So we do a lot of visualizations and these are trends in the market. So I thought it would be good. So if you can understand why we create these graphs, when which graph is required to be produced, we should know some backgrounds about the graphs, why we are using a particular chart or why we are using a particular graph. We should be able to know consciously we should use these things. So why these charts and graphs? Now there might be a big data set. For example, here in this screen you can see. So here box number is given in the first column and the number of resins in each box is given. So same thing is repeated. I have put it side by side because if this I have copied from Excel. So if I put it in a single line, it will be very small. So I have put side by side. If you see this thinner column, this indicates the number of box, which number of box it is, and the next thicker column, it tells you how many resins are there in the box. So now you can see there are 100 observations. 100 boxes are there and how many resins in each box? Such 100 observations are there. Now this is as such not a very big data, but still 100 observations are there. So now how to handle this data? How to handle the large data? Now we introduce this reduction and of the data set to make it manageable. We need to reduce the data set to make it manageable. Now, one way is to convert the ungrouped data into a grouped data. Now here, if you see, so here is only one variable as such. The number of box number can be taken as the index and number of resins, a numerical value. You can say it is a discrete value. So that is there. So there is no grouping. The data is, this is a raw data. Now we need to group this data somehow so that it becomes manageable and we can interpret that data. We have to, if we are given this data set, what interpretation can we have from this data? We need to do something to have a meaning of this data. Otherwise, it is very difficult to understand what this data is trying to tell us. So that is why to handle large data and to make it manageable, we need to ungroup, we need to group our data from ungrouped data. Ungrouped data is the raw data, and when we process it in some way, it becomes a grouped data. So let us see. There are few tools for graphs and charts that we can use to bring out meaning from this data. So if there is one variable, as in our case, we can use histogram, frequency, polygon, ogive, dot plot, bar chart, pie chart, Pareto chart. Then if there are two variables, we can use a scatter plot. So we will see all these charts later on. So just gave you an idea what kind of charts we are talking about. Now let us try to see what are ungrouped data and grouped data. Now here on the left hand side you can see 60 years of Canadian unemployment rates. So it is in series, all these values are given. You can see 5 columns of values. So 60 years means there are 60 values. 5 into in each 12 values are there. You can put everything in a single column in Excel. So 60 years of Canadian unemployment rates. This is an ungrouped data or raw data. Now to bring out meaning from this data, what we are doing is the most basic thing in statistics. We are creating a frequency distribution. Now this frequency distribution of 60 years of unemployment data for Canada, this is a grouped data. Now what we have done here we have formed these classes, class intervals. So 1, 2, 3. For example, here you have these values 2.3, 2.8, 4.6, 3.6, 8.4. All these values are there. 12.0. All these are there. So maybe if you go through this data, you might be seeing that 12 is the largest and maybe 2.3 is the lowest. If you scan through the data, you can see 2.3 is the lowest value and 12 is the highest value. So we are taking a value less than the lowest value, that is 1, and up to 3 we are creating an interval. Then under 3 means say 2.99, 2.9 up to 2.9 but not 3, that is 1 and less than 3. Now the next class we are creating 3 to under 5. So there are two differences, 3 minus 1, 2. So like this we have created 1, 2, 3, 4, 5, 6. So 6 classes, we have class intervals we have created, or you can say these are classes. Now how many points in this raw data or ungrouped data is falling in this bracket 1, 2, 3. If we count, we will find 4. Now how many these points, how many values are coming under between 3 and 5? 12. So like this we have filled in this chart. So here we have found two things. Now this raw data has some meaning. Now the values in the data, you can say if there are 1 lakh values and there might be plenty of class intervals. There might be plenty of class intervals, but that does not happen. The unemployment rate will be following a certain range. It will move between certain range. Like here it is moving from say 1 to 13. So it will not move from 1 to 100. So if it is moving from 1 to 100, then we will make the class intervals likewise. So we divide these values into class intervals and we find out the frequencies. So like this, when this becomes a grouped data from this ungrouped data. So this group data, you can understand some meaning that okay, from 1 to 3 rate, the frequency is 4, 3 to 5 it is 12, and the maximum is 7 to 9, in the range 7 to 9. So this becomes very helpful to study the data. So when we are learning data analytics or artificial intelligence, machine learning, all these things. So statistics is a core part of that, and we must understand these basic concepts. We need not become statisticians, but we need to understand these basic concepts from where slowly, gradually, step by step, some other inferences are found. So that is why it is very important to understand these concepts. Now comes frequency distribution. What we did to get a grouped data from an ungrouped data is called a frequency distribution. What is frequency distribution? It is a tool to group data. So frequency distribution is simply a tool to group the data. So now we have understood we have raw data and we have to handle that raw and large data. We cannot bring out some meaning from an unorganized raw data. So we have to do something to make meaning out of that data. So what is the first step we are doing? We are grouping the data. And when we are talking about grouping the data, frequency distribution comes the first thing. Now, it is a summary of data presented in the form of class intervals and frequencies. So this already we have seen. So I have explained this also. So this thing we are grouping the data and this is called frequency distribution. Now how to create this, how to use Excel and create this type of table, we will come to that. But before that, let us delve into some other things which are important to know. Now to create this frequency distribution, there are certain steps. We will come to these steps, but before that, let us know what is range. Now the difference between the largest and smallest numbers. So here we have the values, 60 values. So here by looking at the data, we found that 12 is the highest and 2.3 is the lowest, or 12 is the maximum value in this data and 2.3 is the minimum value. Now maximum value minus minimum value, we get this. Just for example, I have shown this in a different data set. This will be different. So now we know about range also. Now how to create this distribution table. To create a frequency distribution, we follow the steps below. First, determine the range of the raw data. Just now we saw how to determine the range of the raw data. Determine how many classes it will contain. You may have 5 to 15 classes. So that is the thumb rule, that there should be 5 to 15. If there are very few, say two classes, you can even go without a class. And if there are more than 15 classes, it becomes very difficult to understand the data with so many classes. So it is better that you create 5 to 15 classes. That is optimum. That is a thumb rule. In artificial intelligence language, we call that heuristics, a fancy word. Now determine the width of the class interval. Now what will be the width? Width means what? If I go back here, if you see 1 to 3, so 3 minus 1, 2. So 2 is the width of this class interval. So 5 minus 3, 2. So in every one of these class intervals, 2 is the class width. We call is the class width. So we have to determine the class width of the class interval dividing the range by number of classes. So this is an approximate method. These are some of the steps, guidelines to follow, but it is not that you have to follow this exact mathematics. You can do slightly here and there so that you get the classes. So dividing the range, you have found the range and you have decided upon the number of classes. Now dividing the range by the number of classes, you get, say here in this case we are getting 1.6. Now you can approximate that to 2, the next whole number. Now the frequency distribution must start at a value equal to or lower than the lowest number of the ungrouped data. For example, here we have, if I go here, the lowest value is 2.3. What we have taken? 1. The starting value we have taken as 1. That is, the lowest value is equal to or less than the minimum value. So minimum value is 2.3. We have taken a lesser value of 1. Similarly, you will have the highest value as something more than the maximum value or equal to the maximum value. So here 12 is the maximum value and you have taken 13. So these are the initial values and the last values. Now class endpoints are selected so that no value of the data can fit into more than one class. So what does this mean? So here these endpoints 1 and 3 are defined clearly. So in the first class interval it is less than 3, so that a value, say 3, a value of 3 should not come in the first class interval and the second class interval in both the intervals. It should exclusively come in any one of the intervals. So you have to mention this clearly, otherwise it will be a problem. Now what is class midpoint? So class midpoint is nothing but, for example, here the interval is 1 to 3. Now you add 1 plus 3 and divide it by 2. It becomes 2. 3 plus 1, 4, divided by 2, 2. Then 3 plus 5, 8, divided by 2, 4. So like this, we find the class midpoint, or it is also called as class mark. So these are some definitions we should know. So why this class midpoint is important? It is important because this midpoint becomes a representative of this class interval. this class interval we have mentioned, this class midpoints becomes a representative of the class interval. That's why it is important. Then comes relative frequency. It is nothing but the frequency of a class interval divided by the total frequency. So how to cross check the total frequency? Here it is 60 because I have 60 data points. So the total should always be 60. You must check this. It should not be less than or more than 60. If it is coming less than or more than 60 means there is some problem. So how many data points are there? Depending upon that, this total frequency will be determined. Now, what is relative frequency? For example, here I put this first one 4 divided by 60, that is 1 by 15. If you calculate that, it comes to 0.0667. So like that, we calculate 12 by 60, 1 by 5, 0.2, 13 by 60, we get something this value, 19 by 60, 7 by 5, 5 by 60. So like this, we calculate the relative frequency. So we have found this. So these are some basic steps that we must do to create a frequency table so that it gives us some information about the raw data, and we are doing the grouping of the data to bring out information from the raw data. Then comes cumulative frequency, a cumulative column. You might have done this in many places. So 4, the first one is same as the first one, 4. The next one is 4 plus 12, it becomes 16. Then 4 plus 12 plus 13, 29. Then 4 plus 12 plus 13 plus 19, 48. Like this. And the final one should be equal to the total frequency. These two should match. If it is not matching, something is wrong. You need to recheck. So like this, cumulative frequency will be done. So uh, before we go into graphs and all, so let me just walk you through how to calculate this frequency table in Excel. So let me go to Excel. Okay, hope you are able to see the Excel screen. I'll just enlarge this a little bit so that you are able to understand. So here I have created this frequency table. How I have created, I will show you so that it becomes easy for you to create a frequency table in Excel. Now, this is a hypothetical data experiment, uh, just an example data. The Here we have the week number that acts as the index and average mortgage interest rate in percentage. So we have the percentages. Now here the following data, I'm making it bigger. The following data are the average weekly mortgage interest rates for a 40-week period. Construct a frequency distribution of these data. Calculate and display the class midpoints, relative frequencies, and cumulative frequencies for this frequency distribution. So, as per the steps that we have seen, The steps that we have seen, how to create a frequency table. Just a moment. So here first what we will do, we will try to find the maximum value in this data point. There are 40 data points, so we are trying to find the maximum. So if I write max, how to find the maximum? Equal to, simple, max, maybe you are knowing this. I'll select this value, close the bracket and press enter. So 3.95 is the maximum value. Now we will try to find the minimum value. Minimum value equal to mean. Again we select the data, close the bracket, and we have this mean. So just check the formula out here. Mean, you have selected the data range, it is giving the minimum. Max, you are getting the max. Now range is maximum minus minimum, so equal to, simple, max minus mean. So it is, the range is 0.5. Now number of classes we need to decide upon. How many classes we need? So maybe say I am selecting 6 classes. I am just selecting 6 classes so that everything comes under this. Then width of the class interval. Width of the class interval. So here how to calculate this? Equals to range divided by the number of classes. Enter. So it is coming as 0.08333. I am approximating it to 1. I'm just writing 1 here. So now based on this, see, I am starting at 3.35. So 3.45 is my lowest value. I am starting at a value lower than my lowest value. Then 3.4, 3.35 to under 3.45, 3.45 to under 3.55, because zero point 0.1 is my class width, class interval width. So 0.1 we are increasing. So what I'll do, I'll just copy this and paste it here so that I can show you clearly. I am also copying this. This is manually done, so no formulas are used here. So now what we will do is, we will write down these bin limits. To create a frequency distribution, we need this column. So what will be the bin limits? Bin is 3.35 to 3.45. So the bin higher bin limit is 3.45. So I'll write 3.45. Now it is class interval is zero point 0.1. So what we will do, plus or equal to this plus zero point 0.1. We are just adding zero point 0.1. So clearly this higher class interval I am getting. Now I'll just drag this. So you can see start we have got these bin limits, the higher limits. Now we need to create the frequency of each in class interval. So how to do that? Here look carefully, equal, you have to write frequency, this one. Now you put the data array. What is the data array? Your data itself. You put the data array. Now comma, you can see the formula prompt below. Now beans array. What is beans array? Sorry. One more thing you should remember while calculating the frequency, select all these rows. Now you click equal to frequency, the data array, comma, we have got this, and then the bin limits, close the bracket and enter. So here something is wrong. It should have come in all the rows. It has not come. Let me do it once more. Why it has not come, I'll tell you. Select this. So I am showing you also the mistakes. So you saw that when I pressed enter, the frequency came only in the first row, and that also is not correct. So frequency, again I am selecting this. Now put a comma, then select the bin limits, this one. Now you don't press enter. Last time I pressed enter, it came only in one row, that also is not correct. So what you will have to do is, you have to press Ctrl Shift and then enter. Now it has come. Now if you click on this, you will get this. Otherwise, we were getting a wrong this thing, not wrong, only this one we were getting. If you feel that you can drag this, it is not right. If you drag this, see, I can show you, but you can try this, try at your end, take it as a assignment. Say if you put the frequency formula in one of the rows and drag that, what happens? Now how we will know that this frequency is correct? We will simply select this and make a auto sum 40. So we have 40 data points and we have got 40 here. So we have got the frequencies. So here total frequency. Now class midpoints or class marks. So here what we'll do, this plus this, divided by 2. So first one we'll have to do manually. 3.35 plus 3.45, put it into a bracket and then divide this by 2. You get this. 3.4 is the midpoint value. Now here what you can do is equal to this plus, first start the bracket, this plus this divided by 2. You get this. Now you can drag this. So you have got all the class midpoints. Now relative frequency, it is simple, equal to, you get this frequency divided by 40, the total frequency, and here you should press F4 so that this dollar sign is put, because this is fixed. This cell is fixed. I can press enter. Now I can drag this. So these are the frequencies. Now cumulative frequency, first one will be equal to the first one, then equal to this one plus this one. 6, drag this, you have got. So see, the last one is same as the total frequency. So like this, see how beautifully we have created the frequency table with the help of Excel. I can just color this. This also you can put it in a box. So the same table that we had created here, we have also created here. So now you understand what is class interval, what are bin limits, what are class midpoints, what are frequencies, what are relative frequencies, what are cumulative frequencies, why we are doing this frequency distribution. So all these things you know now. So hope this discussion will definitely help you. So more videos like this, to go through such videos, please subscribe, like and share my channel. So I'll be continuously uploading videos. First we will be working on this statistics playlist, then we will move on to other data analytics or artificial intelligence machine learning topics. So thank you everyone for watching my video. Please like, subscribe and share. Thank you and stay well.